Let's take a look at this problem. We've got x to the third, y to the negative 2, all that raised to the fourth power. There's different ways you can work these. I try to follow my order of operations when I do this, so we have one set way to approach it. Now, order of operations says to do what's inside the parentheses first. Please excuse my dear Aunt Sally. So parentheses. Now, inside of parentheses, I notice I got a negative exponent, and we need to move it opposite where it's at in a fraction, which means we need to create a fraction. You can always create a fraction by putting whatever you have over 1. So now, I'm going to move this y to the negative 2 down to the denominator. When you move anything opposite where it's at in a fraction, the sign of the exponent changes. So the y to the negative 2 becomes y to the positive 2. Now, I just went ahead and dropped the 1 because 1 times y squared will give you y squared. Now, there's nothing left to do inside of the parentheses. So, please excuse. There's exponents inside of parentheses, but I can't do anything with them. But I have an exponent on the outside of this set of parentheses. And if everything inside your parentheses is either multiplication or division, and you're raising the parentheses to a power, you can take everything inside of that power. So I can take the x to the third to the fourth power, and I can take the y squared to the fourth power. So we'll have x to the third to the fourth, and we'll have y squared to the fourth. Now when you raise an exponent to another exponent, you multiply them together. So 3 times 4 gives us x to the 12. And down below, 2 times 4 gives us y to the 8th. And that would be our answer.